Hi, and welcome to my video on rational functions. And this rational function is f of x equals ax plus b times cx plus d divided by ex plus f plus k. And this is number 2. So notice the product here is a quadratic, which is x times x is x squared, divided by a linear, which is degree 1. And A, B, C, D, E, F, K are real numbers. So let's do a couple of examples to graph these. F of x equals x plus 2 times x minus 1 over x minus 2. And the equation is y equals x plus 2, x minus 1 divided by x minus 2. Change the f of x to a y. And we want to graph this, so let's look at the vertical asymptote. Vertical asymptote is you make your denominator equal to 0, and we have x equals 2. And just recall, your denominator of a fraction can't be 0, so this is a vertical asymptote at x equals 2. So there's the vertical asymptote, and the graph of this rational function will not cut through this vertical asymptote x equals 2. Now, as I explained before, x times x is x squared. This numerator is going to be a quadratic and the denominator is a linear. So we're not going to have a horizontal asymptote. We're going to have an OA, an oblique asymptote. And the oblique asymptote, let's change the equation. So if I multiply this two linears out by FOIL, I get x times x is x squared. X times negative 1 is negative 1x. 2 times x is 2x. 2x and negative 1x is x. And the last is negative 2. And we divide by x minus 2. So I change this product of two binomials to a trinomial, and it's degree 2. So we want to find, so there's two ways that we can find. We can take the x minus 2 and divide into x squared plus x minus 2. This is the long division. We could also do it by taking the opposite of x minus negative 2 is 2, and do into the trinomial of 1, 1, negative 2. So there's two ways to do it, and I'll do both ways just to show you. So x into x squared is x, so we put the x above the x, degree 1. Multiply, x times x, x squared. X times negative 2 is negative 2x. Draw a line, we're subtracting, so we add on the opposite, so there's a plus, so we make it a minus. There's a minus, so we make it a plus. By circling it, I know I've done the opposite, so x and minus 2x, x squared, subtract the x squared, and negative x squared cancels out. So 1 plus 2 is 3x. Bring down your next term. X into 3x goes plus 3. Multiply, 3x. Multiply, negative 6. Change, that's a plus, we make it a minus. That's a minus, we make it a plus. 3x, add on negative 3x is 0. And negative 2 plus 6 is a 4. And that gives us the, that's y equals, the quotient is x plus 3, and it's 4 all over the divisor of x minus 2. So that means your oblique asymptote is y equals x plus 3. And just do the synthetic division on that. We bring down the 1. 2 times 1 is 2. Add, we get a 3. 2 times 3 is 6. Add, we get a 4. So again, this is right here, 1 and 3. That's a quadratic. That's 2, 1, 0. This is 1 So this is an x plus 3, and the remainder is 4. So it gives you this. Now we have, that's finding the oblique asymptote. And so now we can go to, let's go to finding the y-intercept. So the y-intercept is when x is equal to 0. So you can take this equation or this equation and let y equal 0. So let's take this one. So we got y is 0 plus 2, 0 minus 1, and 0 minus 2. So that's 2 times negative 1 over negative 2. And that comes out to be negative 2 over negative 2, which is 1. So when x is 0, y is 1. We want to find the x-intercept, and we let y equals 0 in this equation. So we're going to let y equal 0. So we got 0 equals x plus 2, x minus 1, all over x minus 2. And again, two ways. We can put it over 1 and cross multiply, but eventually that x plus 2 times x minus 1 is equal to 0, because if this fraction is equal to 0, the numerator is equal to 0. So x plus 2 equals 0, x minus 1 equals 0, x is equal to negative 2, x is equal to 1. So that means we have negative 2, 0, and we have 1, 0. So let's plot some of these and let's see what we have. Let's plot the horizontal asymptote. The horizontal asymptote is x plus y equals x plus 3, so the y-intercept is 3, which is right here. And the slope is 1 over 1, so we rise 1, run 1, rise 1, run 1. So this is the horizontal asymptote. And we go down 1, right 1, down 1, right 1, down 1, right 1. So this is the horizontal asymptote. Sorry, I say my mistake, my apology. Oblique asymptote. So this oblique asymptote is y equals x. I say horizontal asymptote, oblique asymptote. So there's the vertical and there's the oblique, because this rational function does not have a horizontal asymptote, it has an oblique asymptote. Now, where are we located? Well, we have to go with, let's see, we take another point, so we're either in here and here or vice versa. So let's take a point. Let's take when we want to find x and y. So let's take the point where x is right here. Let's take a 3. So x is 3 to see where we are. So we take a 3 and plug in the equation. So y equals, plug a 3 in here. So 3 plus 2, put a 3 in, is 3 minus 1. And sub a 3 in is 3 minus 2. So that becomes 5, 2, 1. So that's 10. So 3, 10. So 3 gives us a 10. So that's up here. So that means as x goes to infinity, y is going to infinity. So it's this curve is doing this right here. And remember, you can't cut through your asymptote, so if it's passing through this point here at 310, then it has to go up to here, and as x goes to infinity, y is going to go to the line, oblique line, y equals x plus 3. And if we take another point, so let's take another point on this side, which is 1. So let's take 1 and plug into this equation. So we put 1 in, we get 1 plus 2. We put 1 in, and we get, there it is. So I took 1 and I put it in the place of 3. So I have a 3 times 0 over a negative 1. So that's a 0. So 1, when x is 1, y is 0. So it's here. So that means it's passing through in here. So the vertical asymptote is 2. The x-intercept is 0, 1, which is right here. And we got the y, x is negative 2, 0. X is negative 2, 0, so it's cutting here. And x is 1, 0, which is x is 1, y is 0. This is 0, 1. So 0, 1 is right here. So plot all the points. It goes towards this asymptote doing this, towards the oblique asymptote. There it is. And it's in here. So as x goes to infinity, y goes to infinity. And let's show that, because if you think about it, let's look right here at this so infinity, let's say x is infinity. So y, as x goes to infinity, so that's infinity plus 2 is infinity. Infinity minus 1 is infinity. And infinity minus 2 is infinity. So they cancel out, so y is going to infinity. So as x goes to infinity, y is going to infinity. It's going up there. True. Now, what about if x is going to negative infinity? So y, so going to negative infinity, and this one is negative infinity. So they cancel out, so y goes to negative infinity. So as x goes to negative infinity this way, y is going to negative infinity down here. So that makes sense. Hopefully that helps you understand. Again, notice I use the same pattern. I get the vertical asymptote. In this case, I get the oblique asymptote. Y-intercepts, x-intercepts, and find the 2 points or the graph. So note, it'll never cut through a vertical asymptote. So it either goes down here or it goes up there inside. And the key to this one is that because it's a quadratic divided by a linear, then it has an oblique asymptote, which is a line. And that line it won't go through this oblique asymptote. It won't go to the vertical asymptote, x equals 2. And we have one more to do to make sure you help you understand. Again, this equation becomes y equals negative x minus 2, x minus 4 over x plus 1. And we want to get the vertical asymptote, and the vertical asymptote is when your denominator is equal to 0. So the vertical asymptote is x equals negative 1. So there's negative 2, so negative 1 is here. So there's the vertical asymptote. Right down through here, and it's x equals negative 1. Now we want to get what we call, again, because this is a quadratic, which is x squared on the top, if you multiply x by x, you get x squared. And because that's a quadratic divided by linear, we're going to have an oblique asymptote. And the oblique asymptote is, we have to multiply this FOIL. So we do, let me multiply that out right here. So when I multiply, I get first x times x is x squared. Outside, inside is negative 4, negative 2x is negative 6x. And last is negative 2 times negative 4 is 8. So that becomes negative x squared plus 6x minus 8 all over x plus 1. And I want the oblique asymptote, so I'm going to divide. So I'm going to take x plus 1 and divide it into negative x squared plus 6x minus 8. I'm also going to do it by that's plus 1, so I'll make it a minus 1. And we have negative 1, 6, and negative 8. So either way, I'll get the quotient and its remainder. So x into negative x squared is negative x. Multiply back, negative x squared minus x. So we're subtracting, so we change the sign, so that's a plus, and that's a plus. They cancel out. 6, so that's 6 plus 1 is 7x minus 8. X into 7x is a plus 7. So multiply, we get positive 7x plus 7. Draw a line, and as a plus, we make it a minus. As a plus, we make it a minus. There's the minus. So 7x and negative 7 is 0. Negative 7, sorry, negative 8, negative 7 is negative 15. So this equation becomes y equals, the quotient is negative x plus 7, and remainder is negative 15 all over the divisor, which is x plus 1. So synthetic division is quicker. Bring down the negative 1. Negative 1 times negative 1 is 1. Add is 7. Negative 1 times 7 is negative 1 times 7 is negative 7. Add negative 15. So that gives you, there's the negative x plus 7, and the remainder is negative 15. So it gives you this. So that means the oblique asymptote is y equals negative x plus 7. So let's graph that. Plus 7, there's 8, there's 7 right here. There's the y-intercept, the plus 7. And this is the negative 1, so it's negative 1 over 1. So you go down 1, right 1. Down 1, right 1. Down 1, right 1. And we keep going. And we keep, go down 1, right 1. Down 1, right 1. Down 1, right 1. And it's going to cut through right here. Because when x is 7, this is a 0. So this is the oblique asymptote cutting down through these points. There it is. So that's the line y equals negative x plus 7. That's the oblique asymptote. So your graph is the vertical asymptote, oblique asymptote. So your graph is either in here, like this, or it's in here. So it's there, here, or it's in here, like this. So let's find out where that is. Let's find the y-intercept. The y-intercept is when x is 0. So you can take this equation and y equals negative 0 minus 2, 0 minus 4, all over 0 plus 1. So that's a negative of negative 2, negative 4, and 1. So that becomes 3 negatives is a negative. Negative 8 over 1 is negative 8. So that's x is 0, y is negative 8. X is 0 and y is negative 8. So that's down to right there. So that's the y-intercept. What is the x-intercept? So the x-intercept is when you let y equal 0. So 0 equals negative of x minus 2, x minus 4, all over x plus 1. So I took the y and made it a 0. And again, it's to put it over 1 across multiply, or it's this numerator that's equal to 0. So that means we got a negative, so we ignore the negative. So x minus 2 is 0, or x minus 4 is equal to 0. So x is 2, or x is 4. So x is 2, y is 0. X is 4, y is 0. So x is 2, right here, y is 0. X is 4, y is 0. Okay, right here. Got those two. So it looks like it's in here and here. Now, what else will we do? We'll get a point to make sure that this is so. So we know it's in here going, and we have, do we have, so it's, looks like it's, if you see it, it's going through here and coming up, so it looks like it's going along here, because as it has to be in here, so it's going down here, up through here, like this, tapering, and then coming this way. There it is, there's part of it. So let's see what we'll do on the other side. Let's, what happens, we'll take x to be -2. Take it on this side, see if we get a number up here. So if x equals -2, so we got y equals negative. We're putting the -2 here. We're putting the -2 here. And we're putting the -2 here. -4, -6, -1. So we got negative on top, negative on the bottom. So that's a 24. So this x is x and y. X is -2, y is 24. X is -2, y is 24, so that's way up here. So you can see that as like this, it's coming through here and it's doing this. So we can see as x goes to, and just to verify that with this one, let's have a look at as x goes to infinity. Let's look at right here, this equation. X goes to infinity, y is going to, let's see, negative. Infinity, x minus 2 is very close, so it's infinity. That's infinity. X minus 4 is infinity. So if you're going to infinity and take out 4, it makes no difference. You're still going to infinity. And x plus 1 going to infinity is still infinity. So that gives us, they cancel out, negative infinity. So as x is going to infinity, makes sense. Y is going to negative infinity, on down. And what about x going to negative infinity? So we got a negative, and, oh, not here, my mistake, right here. This is negative infinity. This is negative infinity. And this is negative infinity. So they cancel out. Negative and negative is positive, so that's infinity. So as x goes to negative infinity, y goes to infinity. As x goes to negative infinity, y is going up to infinity. So there it is. Oh, I didn't show you this graph. My mistake. So notice it's up here. And so at this point, it's going to this asymptote and coming up to here. So I didn't put that in my previous part of my video. I thought I was high enough. So as x goes to negative infinity, y is going to infinity. And I notice I put in the place of x, I put infinity and negative infinity. Because x minus 2, making it large, minus 2 is still going to infinity. And that's the graph of the horizontal, or sorry, should I say, the graph of the oblique asymptote. The oblique asymptote occurs when your numerator degree is larger than your denominator, and I have a quadratic divided by linear in this case. And this brings us to the end of the video. Again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.